Okay, let's do another example in 5.5. This is example number 1b. I notice here that I have trig with an inside piece, so that's a chain rule. I also have it multiplied by an x cubed, so I see a chain rule and a product rule in there. So that's my clue that we can't do this with our old rules, and we must be using our new rule of U-substitution. So we got to figure out what our u is and then find the du, the derivative of u. And so typically our u is going to be what we call our inside stuff. So to me it looks like my inside here is going to be my x to the fourth plus 2. Let's try it and see. And sometimes you might have to, it's kind of like a puzzle. You might pick a piece, see if it works, and it might not work. You just need to try a different piece sometimes. But on this one I'm going to try my inside as my x to the fourth plus 2. That means the derivative is 4x cubed dx. Are you okay if I skip the step of dividing and multiplying both sides by dx? So I have a 4x cubed dx. And so now I need to be able to plug in all of those pieces, taking out my original pieces, plugging in my u pieces, and make sure that everything's there. And so I have here a cosine of u, right? I have cosine of u that I've substituted in. But in order to have this du, I need to make sure that I have a 4x cubed dx. In order to be able to do this right now, I need a 4x cubed dx. And I don't know about you, but all I see is an x cubed dx. I'm missing a 4, right? And so here's the trick, that if I'm missing a constant, as long as it's just a number, I can actually plug in that number as long as I balance out my original problem and I haven't actually affected its value. So I can put a 4 in there. So that way I can take this 4x cubed dx and call it du, because that's what I need. So I'm going to plug in a 4. But in order to balance out my problem, I need to go back through and I need to divide by 4, or can I say multiply by 1/4? Because think about that. If I multiply by something by 4, but then divide it by 4, I haven't really affected its value. I'm still legal. But now I have this 4x cubed dx that I can call my du. So again, I plugged in a 4 because I needed that for my du. Rewriting my problem, I have a cosine of u, and then the rest of this is my du. That's where the pink comes in. But now, don't I still have that 1/4 from the front? So that 1/4 in the front doesn't go away. The 4 goes with my x cubed dx, but my 1/4 stays there. And I'm allowed to do that as long as it's a constant and I balance it out. So now I have an integral with all of the pieces substituted in. I needed that extra 4, but that's okay. I balanced it out with my 1/4. So I have all the pieces that I need, no extra. Everything's good to go with one variable now. So now what's the antiderivative of cosine? Well, you should get sine of u, right? Or 1/4 sine of u, making sure that you bring the 1/4 with it. And not only a 1/4 sine of u, but remember your plus c, your constant of integration in the back. Please don't leave your answer in terms of u. We really want the antiderivative in terms of x's. So the very last step is we need to back substitute. So what did we call u in the first place? Well, we called u the x to the fourth plus 2. So let's finalize our answer and get an antiderivative of 1/4 sine of x to the fourth plus 2 plus c. Okay, so that's an example of where you might have to add a constant in there. As long as you make sure you balance it out, that's legal. It just can't be a variable. If you have an extra variable or you're missing a variable, then you need to do something different. Okay, let's look at C and D also in this video. If you're looking at C, I don't know about you, but the first thing I notice is a little bit of a red flag. That normally as soon as I see that radical, I change it to a 1/2 power. But as I'm looking at this, to me this looks like a chain rule problem, right? Where I can't make it look any nicer necessarily. And so that's my clue that I'm going to use U-substitution. So why don't you stop the video, see what you think U is, see if you can find du, and see if you can plug in all your pieces and make sure that they all match. I called u 2x plus 1, the inside piece. So that means the derivative would be 2 dx. And so now I'm going to try to take out all of my pieces and substitute in u instead. So to me, I have a u to the 1/2, but in order to have my du, I need a 2 and a dx, and I don't have a 2. But as long as I'm just missing that 2, I can plug the 2 in so that this can be called my du. But if I plug in a 2, I've got to balance it out with a 1/2, so I'm not affecting the value of my original problem. So now rewriting it in terms of u, I end up with a u to the 1/2 du with a 1/2 in the front. Did you get that? Hopefully. All right, now we have an integration problem with just a single term. We can use power rule. We can find the antiderivative by adding 1 to the exponent and dividing by that new exponent. So I got u to the 3/2 times 2/3 times the 1/2 that was out there at the beginning, plus c. My 2's reduced, and so then I was left with u to the 3/2 over 3 plus c. But let's make sure we finalize our problem back substituting in what we called u in the first place, which was our 2x plus 1, and get a final antiderivative that looks like this. Let's do one more in this problem. Look at D. To me, D looks like a quotient rule and a chain rule. The first thing I did was I rewrote it with a 1/2 exponent. So again, quotient rule and a chain rule. And so that's my clue that we're going to have to use our substitution rule. Try this one, pause the video, see what you think u is, see if you can find the correct du, see if all your pieces match. If you're missing a constant, you can plug it in as long as you make sure you balance it out. So pause the video, take a few seconds, and see if you get the same thing I do. I decided that my u was going to be 1 minus 4x squared. The derivative then is negative 8x dx. Going back to my original problem then, this would be u to the 1/2 on the bottom. But in order to have a du, it looks like I'm missing a negative 8. So I can put a negative 8 in there, which would make this whole top piece, the negative 8x dx, my du. So I have a u to the 1/2 on the bottom, and I have a du on the top. But I can't just substitute in a negative 8 without balancing out with a negative 1/8 on the outside. So rewriting my problem in terms of u, I ended up with a du on the top, on my numerator, over a u to the 1/2 with a negative 1/8 in the front. And I don't know about you, but I didn't really like that du on the top, so I moved it over to the side. I hope you're okay with that. And then it looks like you can even bring this u to the 1/2 up top and make it u to the negative 1/2. That makes me feel better. Now I can use my power rule. I can add 1 to the exponent, divide by that new exponent. Don't forget you have a negative 1/8 in the front, and don't forget you have a plus c in the back. So I ended up with this. Reducing and back substituting, you should get a final antiderivative of negative, and then the quantity 1 minus 4x squared to the 1/2 power, all over 4, plus c. I hope your puzzle pieces are fitting. I hope it's all making sense. We're doing a great job. We're almost done. We'll do another video here with a few more examples, adding some trig in there, and adding one more piece eventually into it.